Good morning, friends. After the discussion of the atoms in chapter 12, we discussed about the Rutherford's atomic model and also the postulate suggested by the Niels Bohr in Rutherford's atomic model. Today, we start our discussion about the nucleus or the nuclei, chapter 13. Here the first question is that what is the nucleus, and that the brief story or the explained in brief about the nucleus. Right? So we are using the concept of the Rutherford's atomic model. Rutherford suggested that the small central region in which the entire positive charge and most of the mass of the atom is concentrated. This small central region is known as the nucleus. Again, Rutherford suggested that, or in Rutherford's atomic model, the small central region in which the total positive charge of the atom and most of the mass of the atom is concentrated. This small central region is known as the nucleus. Already we know that there is the atom. Entire mass of this atom and entire positive charge is concentrated in small central region that is known as the nucleus. Here the positive charge is lying in small central region. Therefore, the question is define nucleus and give information of the nucleus. According to the Rutherford's atomic model, the definition of nucleus is the total positive charge and most of the mass of the atom is concentrated in small central region of an atom, which is known as nucleus. The dimension or the radius of the nucleus is much smaller than those of an atom. There is a very small region of the atom, nucleus is. Therefore, the radius of the nucleus is very small compared to the radius of the atom. The experiment of the scattering of the alpha particle also shows that the radius of the nucleus is smaller than the radius of the atom by factor of about either 10⁴ or 10⁵ times. So radius of the nucleus is very small compared to the radius of the atom already we discussed in chapter 12 atoms. There is a smaller by the factor about 10⁴ or 10⁵. Therefore, the volume of the nucleus to the volume of atom is equal to 4/3 pi r cube. R is the radius of the nucleus. Approximate we consider 10⁻⁴. While in chapter 12 we also discussed about the Rutherford estimate the radius of the nucleus of an atom is in order of 10⁻⁻15. But in this chapter, our textbook, that is given 10⁻⁴. For that purpose, I consider here the radius of the nucleus is about 10⁻⁴ meter. Whole cube divided by 4/3 pi, radius of an atom in order of 10⁻⁻10 cube, therefore 10⁻⁻12. The volume of the nucleus is about 10⁻⁻12 times the volume of an atom. And also, inside the nucleus, just we discussed about the nucleus, definition of nucleus. Nucleus contains the total positive charge of the atom. Therefore, the nucleus contains most of, that means the 99% of the mass of an atom, and also inside the nucleus the positively charged proton and chargeless neutron are present, because the total positive charge is concentrated in the nucleus and most of the mass of the atom is also concentrated in the nucleus. Again, what is the definition of the nucleus? According to the Rutherford's atomic model, the total positive charge and most of the mass of the atom is concentrated in small central region of an atom. This small central region is known as the nucleus. The dimension or the radius of nucleus is much smaller than those of an atom. The experiment of the scattering of alpha particle also shows that the radius of the nucleus is smaller than the radius of the atom by a factor of about 10⁴ to or 10⁵. So now let's take the ratio of the volume of nucleus to the volume of atom. Therefore, the volume of nucleus to the volume of atom we obtain, that is the 10⁻². Thus, the volume of nucleus is about 10⁻² times the volume of the atom. Therefore, the volume of the nucleus is very, very small. If we consider our room is atom, so compared to the volume of the room, the nucleus of this room is like a pinhole. Like a pinhole. That means the very, very small. So the nucleus contains the most of the mass, approximate 99.9% mass of the atom is concentrated in a small central region, that means the nucleus. And nucleus contains the total positive charge. That means the positive charge proton and chargeless neutron are living in small central region, that is the nucleus. So in short, inside the nucleus, 99% mass of the atom and the positively charged proton and chargeless neutron are present inside the nucleus. Right? After the definition of the nucleus, in this chapter, we are going to discuss about how we measure the radius of the nucleus. Right? How the radiation takes place from the atom, due to the which process take place. So, electromagnetic radiation takes place in terms of the alpha particle, beta particle and gamma particle. And in which circumstances the nuclear process, nuclear fission and nuclear fusion process take place. So as a result, one element is converted into the another element. Right? After that, they define the atomic mass unit. What is the atomic mass unit and why the atomic mass unit is required? Now, the mass of an atom is very small compared to kilogram. So, kilogram is not convenient unit to measure such small masses. Because the atom is not shown by our naked eye, the dimension of the atom is also very, very small. So, for the small atom, it is not convenient to measure the mass of this atom in kilogram. Therefore, in atomic and nuclear physics, the unit of mass is taken as atomic mass unit. Again, the nuclear and atomic physics, the unit of mass is taken as atomic mass unit. It is also denoted by unified mass, and that is denoted by U, small u. Right. What is the definition of atomic mass unit? The 12th part of the mass of unexcited carbon atom is known as atomic mass unit, or the 1 AMU, or 1 U only, unified mass. Again, the 12th part of the mass of unexcited carbon atom is called as the 1 atomic mass unit. Again, what is the atomic mass unit? The mass of an atom is very small compared to the kilogram. So, kilogram is not convenient unit to measure the such small masses. That is not convenient to measure the mass of the atom in kilogram. Therefore, in nuclear and atomic physics, the unit of mass is taken as the atomic mass unit. It is also denoted by unified mass, that means the small u. Now, what is the definition of atomic mass unit or unified mass? The 12th part of the mass of unexcited carbon atom is known as one atomic mass unit or one unified mass. So how we obtain the relation between unified mass or the atomic mass unit with the kilogram? Therefore, from the definition, one atomic mass unit is equal to mass of unexcited carbon 12 atom divided by 12. Mass of unexcited carbon atom is 1.992647 into 10 raised to minus 26 by 12 kg. So as we simplify, we obtain the value is 0.166 into 10 raised to minus 26 kg. Therefore, one atomic mass unit is equal to 1.66 into 10 raised to minus 27 kg. That is the relation between the atomic mass unit and kilogram. So keep in mind this relation frequently we are using in numerical. One atomic mass unit is equal to 1.66 into 10 raised to minus 27 kg. So how we can measure the atomic mass of the atom? For that purpose, the mass spectrometer is used to measure the atomic mass of an atom. The mass spectrometer is used to measure the atomic mass. Keep in mind this sentence for 1 mark MCQ type question. Again, we define the atomic mass unit. The 12th part of the mass of unexcited carbon atom is known as one atomic mass unit or the 1 U. How we obtain the relation between atomic mass unit with the kg? Therefore, one atomic mass unit is equal to mass of unexcited carbon atom divided by 12. Is equal to 1.992647 into 10 raised to minus 26 kg is the mass of one carbon atom divided by 12. After the simplification, we obtain 0.166 into 10 raised to minus 26 kg. Therefore, one atomic mass unit is equal to 1.66 into 10 raised to minus 27 kg. The atomic mass of an atom is measured with help of the mass spectrometer. Clear it? Okay. After the discussion of what is the nucleus and what is the atomic mass unit, now we are going to define the some term we are using for the nucleus. Like as the what is the atomic number, what is the atomic mass, what is the neutron number, what is the nuclei. So for that purpose, first definition of the nuclei. The types of the nucleus is known as the nuclei and is represented by a symbol. The different type of the nucleus are generally known as the nuclei and represented by a symbol as X, Z, A, this way or this manner, Z, X, A. X is the chemical symbol of an element, while here Z is the atomic number, A is the atomic mass of this element. Again, what is the nuclei? The types of the nucleus is known as the nuclei and is represented by a symbol X, ZA or ZXA. Here Z is the atomic number and A is the atomic mass. A represents the total mass of this element and Z represents the number of protons or the position of this element in periodic table. Position of this element in periodic table, that is represented by the atomic number. After that, what is the atomic number Z? The number of electrons in the atom and hence the number of protons in the neutral atom is known as the atomic number Z. What is the atomic number? the number of electrons in the atom or the element and the numbers of protons in the neutral atom is known as the atomic number Z. So in this symbol, here the Z represents the total number of the proton or the total number of electron in an atom. What is the mass number? The total mass of proton and neutron in the nucleus is known as the mass number. So already we know that inside the nucleus positively charged proton and chargeless neutron are present. The total mass of proton and total mass of the neutron, the sum of these two mass, that is known as the mass number. Again, the total mass of proton and neutron in the nucleus is known as the mass number. Right? After that, what is the nucleon? Capital A. The sum of number of proton and neutron, that means the Z plus N present in nucleus is known as the nucleon. Capital A. The sum of number of proton and neutron, Z plus A, present in nucleus is known as the nucleon. That means commonly the proton and neutron are known as the nucleon. What are the small particles living in the nucleus are known as the nucleon. The sum of number of proton and neutron present in nucleus, that is known as the nucleon, that is denoted by capital A. Therefore, capital A is equal to Z plus N. Z is the number of proton, N is the number of neutron in a nucleus. What is the neutron number with the capital N? The number of neutrons present in the nucleus of an atom is known as the neutron number, capital N. From this equation, A is equal to Z plus N. Therefore, N is equal to A minus Z. A minus Z. That gives the number of neutrons. So in short, the number of atomic number is subtracted from the nucleon. So we obtain the number of neutrons. For example, nuclei of the bond AU 7997. 79 is the number of proton. That means there is our Z. There is our Z. Now, 197 is the total number of nucleon. There is our A. And number of neutron, 197 minus 79. That means the N is equal to A minus Z is equal to 197 minus 79. Therefore, 118 neutron. Therefore, in nuclei of gold, AU 79, 197 nucleon, 79 proton, and 118 number of neutrons are present in nuclei of the gold. Again, what is the nuclei? The types of the nucleus are known as the nuclei, symbolically represented by XZA or the ZX. Z is the atomic number, A is the atomic mass. That means the Z is the atomic number of proton and A is the total number of nucleon in a nucleus. Yeah. What is the atomic number? The number of electron in the atom, and hence the number of proton in the neutral atom is known as the atomic number Z. After that, what is the mass number? The total of mass of proton and neutron in the nucleus is known as the mass number. What is the nucleon? Capital A. The sum of number of proton and nucleon, the sum of number of proton and neutrons in the nucleus is known as the nucleon. Therefore, A is equal to Z plus N. A is the total number of nucleon, Z is the number of proton, and N is the number of neutron. After that, what is the neutron number? The number of neutrons present in a nucleus. The number of neutrons present in the nucleus is known as the neutron number. So from this equation, N is equal to A minus Z. For example, the nuclei of gold, Au 7997. 79 represents the atomic number Z, that means the number of proton. 197, that represents the number of nucleon, capital A. And therefore, the number of nucleon N is equal to A minus Z is equal to 197 minus 79 is equal to 118 nucleon. Therefore, in nuclei of gold, 118 nucleon are present in the nucleus of a gold. After that, the other definition, what are the isotopes, isobar, isotons and isobars? With the example. So first, what is the isotopes? The atoms having the same atomic number Z, but different atomic mass number A. Again, the atoms having the same atomic number Z, but the atomic mass number A is different. Such atoms are known as the isotopes of each other. Again, the atom having the same atomic number, Z is same, but the different atomic mass number is different. Such type of the atoms are known as the isotopes of each other. As an example, isotopes of the hydrogen are 1h1, 1h2, 1h3. Right? So in 1h1, one proton present, neutron is 0. Total number of nuclei is 1. Here in 1h2 deuterium, 1 proton, 1 neutron, and total number of nucleon are 2. Now 1h3, 1 proton, 2 neutron, and total number of nucleon are 3. These are the isotopes of the hydrogen because the number Z are same but the A are different. So 1h1, 1h2 and 1h3 are the isotopes of the hydrogen. Gold has 32 isotopes. Gold Au 79.97 has the 32 isotopes. In addition, carbon C612, carbon C613, carbon C614 are the isobaric nuclei of carbon. Are known as the isobaric nuclei of carbon. These are also the isotopes because the atomic number Z are same but the A are different. Right? Now, one more example, uranium 92 to 33, uranium 92 to 35 and uranium 92 to 38 are the isobaric nuclei of uranium. And also for lithium, lithium 3, 3 lithium 3, 3 lithium 4 are isotopes of lithium. So these are the example of the isotopes of carbon, uranium, hydrogen and also the lithium. Again, what is the isotope? The atoms having the same atomic number Z but the different atomic mass number A. Such type of the atoms are known as the isotopes of each other. So here the Z is same for the atoms while the A are different. Therefore the isotopes of the hydrogen are 1h1, 1h2, 1h3. Now the carbon has the isotope C612, C613, C614. Uranium has the isotopes 92 to 33, uranium 92 to 35, uranium 92 to 38 are the isotopes of the uranium. While for the lithium, 3 lithium 3, 3 lithium 4 are the isotopes of the lithium. Gold has the 32 isotopes. Now next definition is the isobar. The atoms having the same atomic mass number A but different atomic number Z and number of neutrons are known as the isobar of each other. Now isobar, A is same but the Z and N are different. A is same but the Z and A are different. The atoms having the same atomic mass number A but different atomic number Z and atomic neutron number N. are known as the isobar of each other. So for isobar, A say Z and N different. Now in isotopes, Z is same, A different. Again for isobar, the atoms having same atomic mass number, but the atomic number Z and neutron number are different. Such types of the atoms are known as the isobar of each other. Now example, hydrogen 1 and 3 and 2He3 helium. Both has the atomic mass number A are same. A is equal to 3, A is equal to 3. But in hydrogen 1 and 3, the atomic number Z is equal to 1, while helium Z is equal to 2. Number of neutron in 1 and 3, 2, while 2He3, the number of neutron is 1. So here the atomic mass number are same of 1s3 and 2He3, but Z and N are different. Therefore, 1s3 and 2He3 are the isobar of each other. Other example, lead 82214 and lead Pd 83214 are also the isobar nuclei. Clear? So this is the definition of the isotopes and isobar.